First thing we're going to go through is look at scope, and scope is the definition of how any piece of data, be it a variable, a string, anything like that, is its level of accessibility, so what parts of your code can actually reach that bit of data. So we do have, just like the previous examples, we have the scope examples and then the data type examples. And what we're going to do is we're going to go through and get a little hands-on and try a few of these. So the first thing I want you to do is go ahead and create a variable. It could be any number, string, anything like that. And then what we're going to do is create an if statement. And we're going to see if that variable equals whatever you assigned it. So if you put 4, put it for 4 is here. So this is creating a local statement that's going to be true. And what we're going to do is we're going to create a local variable to this statement. So we're going to do local variable, and then you can assign it any value, and then we're going to print that value. And then we're also going to print that value outside of the if statement, like so. And we'll see here that it prints 36, it prints the correct value. Oops, we want to put the value there. It'll print this 36 correctly here, but the second time it actually prints a nil. The reason being is that this variable only exists within the local scope of this statement. So between this if then and the end, this is the only place that this new var exists because it was created locally, the local that you put before the variable, to this statement. So if we had a second if statement, equals 1 plus 1, let's see that, and we created a new var, and we made it anything like that, and then printed it again, you'll see now we'll have it print 36, 44, and then nil because it doesn't exist within this scope. So the new var here and the new var here are actually different variables. They aren't the same variable because they're both created locally within this scope, separate of each other. So this new var exists as long as it's in here, and this one exists as long as it's in this statement, so until the end is reached. So these are completely different. We may be using the same name in this sense, but for your consideration, because of the scope, they are actually different variables. And neither of them exist outside of this statement, so that's why we still get a nil here. So to give another example, we're going to use a function. And we'll name it local example. And let's try passing new var. So we're going to go ahead and call the function here. So we're going to call local example, and we're going to pass, we're going to pass new var. So now we're calling this function with new var being called, and we have an issue. Let's take a look. So the issue here is that this function needs to be created first because Lua reads from the top down, so the function didn't exist yet when we called it here. So now we're calling this function, passing it new var, passing it this local variable. Now we're passing it as arg. Now arg, when a function is created, it's creating these arguments as local variables. So now arg is its own entity. So when we print new var, we'll get 36. Then it calls this function, passing new var as an argument here. Then it prints arg, so we get a separate 36. Let's go ahead and delete this one as well. So if we change arg, so arg equals arg plus 1, and then print it, you'll see that we'll now get a 37 because it's printing the change to arg. But if we printed new var again, we'll see that it's still 36. So the order it's printing here, then it calls this function, so then it runs this code, prints this twice, and then it prints this once this is done. So we should have 36, then it goes here, 36, then it adds 1, 37, then it finishes this, and it goes here, and we get another 36. So when we change arg, we're not changing new var because they're both local to their statements. So this arg is local to the function, whereas new var is local to this if statement. Now to give a further example, let's go ahead and just work in this function. If we have if, say 4 equals 2 plus 2, then we can create multiple local variables within various scopes. So we're going to put local new var equals 6, and then in this if statement, let's make local second var as 27. Now, in this if statement, we can print new var, and this will function because new var is within this scope. It's within the function, so new var will print. And we can print second var here within this if statement, and it will print. We gotta call the function though. So now we'll see the prints here. So it's printing new var as 6, then it's printing second var as 27 in this if statement. But if we print second var outside of the if statement, we're going to get a nil. And the reason because is this second var is created locally in this statement. So even though it's created locally within the function, it's also within this if statement. So as soon as this if statement is over, it's no longer available, even though it's in this function. So local is based on whatever statement block you're in, be it an if statement, a function, a for loop, anything like that. Local objects exist within the last statement called. So that's the basics of local scope. We'll be using this a little more hands-on later in some of our more advanced examples, but you should just keep in mind that a local object exists only within the scope that it's created for. So there's a few examples that you can take a look at here as well. Next up, we're going to be covering data types in Lua. There are 8 basic data types in Lua. We're going to go through 7 of them now. You can take a look at the data types example file. There's actually a link here to the Lua manual, and this covers in detail the 8 different types. What we're going to do right now is just look at a few and get some examples of how to use them. So first up, we're going to look at nil. So we've seen quite a bit when something is printed and it doesn't actually exist, it comes out as nil. What we'll do here is we're going to go ahead and assign nil to var and print it. See, we get a nice print as nil. Now let's also try printing new var. We'll see that that also comes out as nil because new var does not exist. So if we gave variable a number, gave var a number, we'll see that we get 1, but then we get nil once again because this doesn't exist. So nil is basically the holder for anything that doesn't actually have any value or any structure. So if we were to assign something and then take it away, it would still become nil. So we have here that var is 1. If we then made var be nil and printed it, then we'll see that var goes to being nil because it's being assigned as such. Now with a nil value, you can't make any major changes to it, so var can't be on the right side of an expression. So if we say var equals var plus 1, and then we print it, we'll see, var will come out to 2, there's not a trouble here. But if we made var equal nil, and then try to do var plus 1, it's going to fail because you can't add 1 to nothing. So nil isn't 0, it is absence of value. So absence of value plus 1 does not exist, so that will cause a failure. So whenever a value is nil, it can't be part of an expression, an arithmetic expression. Now we can compare it to something. So we could do if var equals 2 then, and this will come out to false because var is absence of value, which is not equal to 2. And another important one here is, let's go ahead and print here. We'll see that with this one, we don't get this print statement because var technically is not false. While it doesn't exist, it isn't actually false, which brings us to our second data type, which is Booleans. So Boolean has one of two values. It's either true or false. So if we said var equals false, then var is a Boolean with a false value. So this is very simple type. There are only two options. Var is false, var is true. And of course, as we've gone over before with statements, true and false are used in if statements as a comparison to determine whether something should be carried on in a statement. So if we did if var, then this will come through because var is equal to true. So we'll get this print statement of true. But if we made var be false, then we're not going to get a print statement because this is false. This comes out to be false. So an if statement only comes through if what it comes out to in the expression here comes out to a Boolean of true. So that's the basics for Booleans. Next up, we're just going to go over numbers. So numbers are, as it sounds, a number. So if we say var is 3, then we print var. It's going to print out the number 3. And of course, numbers can be used in expressions of arithmetic. So you can say, anything like something like this will work with numbers. Now, if we were to put a string in here, let's do that. You'll see that it fails because it's attempting to perform arithmetic on a string value. So you can only perform arithmetic on a number. So that's numbers. So let's go ahead and take a look at strings now. So strings are strings of text. So to go to the most basic example we had before, hello world. So they are strings of text. They can't be used in arithmetic, as we just saw. You can do comparisons of them, so you can do an if statement. So we could say if var equals hello world. And if it is exactly the same string, this will come through as true because it is comparing to see if they're the same items. So if we were to print here, you'll see it prints as hello world because var does equal this. Now, if we were to change something like the capitalization here, we're going to see that we don't get this print statement because they now are not exactly the same. So you can use strings to compare them to others and to do various elements like that. We'll go over some of the more advanced string API in the next section. Next up, we're going to go ahead and take a look at functions. So we've kind of just went over functions, but a function is actually a data type. And functions can be created in two ways. The ones that we went over before, where you call function, then the name of the function. But you can also do an expression the same as any other data type and tell it that it's a function. And this is the same as this. These two operate in the same way. It's just a different way of visually structuring it. Generally speaking, you're going to see the majority of functions done in this first form, but in some situations it's advantageous to use this structure. So that's a function. We went over functions in section 6 quite in detail, so we're going to go ahead and move ahead. Now we're going to go over user data briefly, but we don't have any specific examples outside of Corona for the moment. So user data is any data type created in C in the back end of Lua for the structure of the code. So what we're going to do is we're going to make a display dot new circle, give it its values. And we're going to go ahead and see that creates this. So what this is actually doing is creating what's called in Corona a display object. So a display object is a user data type created by Corona. So if we said, let's say var is var plus 1, we're going to get a failure because you can't add 1 to this value. Because var is not a number right now, it is in fact a user data type. So this is user data types. We'll be using a lot of user data types in Corona, the display objects and some various other types of user data, but we're not actually going to be creating any user data types in our examples. Lastly, so we're going to skip threads. So threads are basically the specific thread of Lua running. So if you had more than one Lua program running at once, they would be separate threads. You can read more about them in the manual. But the last one we're going to cover is the table. So tables are very important. The core of what you'll be doing in Lua is using tables. So a table is defined by two curly brackets. That creates a table. So right now var is a table. It's an empty table and there's nothing in it. And if we try to print it, we'll see that we get just a hex code, because this is pointing to the memory. It's not actually able to print a table. So let's go ahead and give this table some values. So when you create a table, you give it values separated by commas. So let's give it 4 values here. So now what happens is we actually have a table with 4 pieces of information in it. And if we were to, let's say, print var, then with square brackets 1, this is going to print the first value, which is the first one we provided. Now if we try printing var2, we're going to see that it prints 5, because 5 is the second value that we've given var as a table, and so on. So 3 will be 2, and the 4th value will be 7. So that's the basics of a table. Now tables can be a whole collection of items. They don't need to be just numbers, they don't need to be just strings. You can use a whole variety here. So if we printed var1, then we'll see that var1 is still 1. If we do 2, then it's going to print hello world, and so on. So tables can be used for a wide variety of other data types. In fact, in a more advanced tutorials later, we'll see that you can actually put a function in a table, and that function will serve as an object in this table. So it's a table function. This is very important for later when we'll be dealing with actually creating objects internally in various elements. So we'll go to those much later. Alright, so what I'm also going to show you now is the meta table structure of Lua. So the meta tables are any table that's created that doesn't use numbered indices. So we were seeing earlier we had var1, var2, and they're all numbered structures. But let's try creating var as an empty table, and then giving it var, instead of putting a number in here, we're going to put hello world. And we're going to make that equal 1. So what we've done now is in var, we've created an element with the name hello world, the key hello world, and then the value of 1. So if we were to print var hello world, we'll see that it's going to print 1. Now, this is one way of showing such a metatable item, but another is you can do var dot, let's say var dot hello equals 2. So these two that you see here are in fact the same structure. The same as how we saw that functions could be done in 2 different ways. Var dot hello is the equivalent of var and then hello in parentheses. So you'll see that it's printing 2 because we assigned 2 second, but if we print it this way, it's going to print 1 because this is the second one that's given. So tables can be done in a variety of ways. The important thing to consider here is that a table can be used as what's called in many languages an object. So what we can do is we can say var.x is 1, var.y is 24, var.radius is 30, and then we could create, let's say, a circle and give it var.x, var.y, and var.radius. And now we will have created a circle using these values. So it's very useful to create a table and to use these meta tables as a structure for your data. Because if we just had var1, var2, and var3 here, it'd be very hard to keep in memory what is the radius, what is the x, what is the y. You'd constantly have to remember that 2 is y, 3 is radius, etc. So it's much easier to use a meta table like this and actually have named values having these keys for all of your data. So we'll be using the tables quite a bit as we go, and we'll see more examples of those in later sections. So there you have it. Those are the data types and the scope in Lua. Our next section will be covering some of the Lua API elements that we'll be using throughout our Corona tutorials. Thank you.